Just to quickly repeat what I finished the last clip on, because I didn't say all that in class. We've concluded that the work done here, the positive work done here, the work done here, the negative work done here, if we add those up, they got to add up to 0, which means that the positive work has to be equal and opposite to the negative work. The work done here is equal and opposite to the work done here. It doesn't look that way. This vector is bigger than this vector, and this vector appears to be somewhat bigger than this vector. So if we multiply these, we don't get something of the same magnitude we get when we multiply these. The flaw is in the picture. This vector is actually probably at a greater angle with respect to horizontal than this one. And my weight vector here is too long because the weight vector here has to be the same as the weight vector here. It's the same ball, has the same weight in both cases. So to modify this, we'd have to make the angle shallower, which would reduce the projection and match the picture. And we'd have to shorten the weight vector to where the product of this displacement and this displacement would end up being equal to the product of, the product of this projection and this displacement would end up being equal to the product of this projection and this displacement. You can understand that if we have a shallow angle over here, that the projection of the vector would end up much shorter than it would over here. If the slope of this incline is a lot less than the slope of this incline, it's clear that we're going to have a shorter projection, which means we're going to have a longer displacement vector in order to balance the work. Remember again, the negative work here has to equal the positive work here. And from work energy considerations and from just the pictures, we can see why, in the absence of friction, the distance rolled on the second incline would then have to be greater than on the first. Again, on the condition that the slope of the second incline is less than the slope of the first.